Hello, welcome to this lesson. In this video, we are going to learn about the probability of an event. So for a discrete sample space, the probability of an event E, which is denoted by P of E, is equal to the sum of the probabilities of the outcomes in the event E. So that's what the probability of an event means. So for us to better understand this, we are going to solve this example here. So let's look at that. The question says that a random experiment can result in one of the outcomes, which is A, B, C, and D, with probability 0 0.1, 0 0.3, 0 0.5, and 0 0.1 respectively. Let A denote the event AB, let B be the event B, C, D, and then let C be the event D. So we've been given a sample space. The sample space is A, B, C, D, and then we have events A, B, and then C. So we are going to be asked to find the probabilities of the event and then combine events. So let's look at that. So for event A, we have the following outcomes. Which is A and then B. And then for event B, we have the outcomes B, C, D. And then for event C, we have the outcome D. So you know that each of these outcomes has been assigned probabilities. And then we know that the probability of an event is equal to the sum of the probabilities of what each of the outcomes in the event. So I'm going to apply this to solve this question here. So the first question says that we should find the probability of A, probability of B, and then probability of what C. And then you know that A, B, and C are events. And then we just learned that the probability of an event is the sum of the probabilities of the outcomes in the event. So now let's apply this. So if you take event A, we have the following outcomes A and then B. And then each of these outcomes have been assigned a probability values. So we've been told that the probabilities of the outcomes are 0 0.1, 0 0.3, 0 0.5, and then 0 0.1 respectively. So that tells us that the probability of A is what 0 0.1, that of B is 0 0.3, that of C is 0 0.5, and then that of D is what 0 0.1. So considering the probability of event A, that will be equal to the sum of the probabilities of what the outcomes in what A. So you know the outcomes to be A and B, and then the probability of the outcome A is what 0 0.1, and then that of what B is what 0 0.3. So you are going to add these two to get the probability of what event A. So you are going to have 0 0.1 plus 0 0.3. So when we do this, we are going to get this to be equal to 0 0.4. So that will be the probability of the event A. So let's do same for the probability of event B. So event B, we have the following outcomes B, C, D. And then let's look at their corresponding probabilities. We are going to have D. For B, we have 0 0.3. For C, we have 0 0.5. And then for D, we have what 0 0.1. So the probability of B, event B, will be the sum of the probability of what each of the outcomes. So we're going to have 0 0.3 plus 0 0.5 plus what 0 0.1. So this will give us a value of what 0 0.9. So now let's look at the third one for question one, which is that we should find the probability of C. We know that for event C, we have the outcome D, right? And then the probability of the outcome D is given as what 0 0.1. So we're going to have the probability of event C to be what 0 0.1. So now let's look at the second part of the question also. So question 2 says that we should find the probability of A complement, right? So we know event A. So for event A, we have A, B, right? And then A complement will be the outcomes that are in the sample space. The outcomes that are in the sample space but are not what event A. So for those outcomes, we are going to have C and then D, right? Because C and D are in the sample space, which is this sample space here, but they are not in what event A. So we are going to have the probability of A prime, okay, to be equal to the sum of the outcomes in the A complement event. So we are going to have the probability of C, which is what 0.5, right? And then plus the probability of what D, which is what 0.1. So this will then give us a value of what 0.6. So that will be the probability of what A prime. So let's find that of B prime. Okay, so let's find B complement. So B complement, okay, we know that for B we have B, C, D. So for B complement, that's going to be just A, right? So B complement will just be A because A is the only outcome in the sample space that's not in the event B. Okay, so probability of B complement will just give us the probability of outcome A, which is what 0.1. Okay, so now let's find the probability of C complement. Okay, so let's look at that. So for C complement also, the outcomes that are not in event C, okay, we're going to have C complement to be the outcomes that are not in event C, and then those are A, B, and then C. Okay, those are A, B, and C. So let's find the probability of C complement. That will be the probability of outcome A, which will be what 0.1, plus that of outcome B, which will be what 0.3, plus that of what outcome C, which will be what 0.15. So this will also give us a value for 0.9. Okay, so that's for the second part. Okay, so now let's find the probability of question 3. Let's find the probability of A intersection B. Okay, so for that one, let's list event A. Okay, for event A, okay, for event A, we have the following outcomes, which is A and B, right? And then for event B, we have the outcomes B, C, D. Okay, B, C, D. So now let's find A intersection B. Okay, let's find A intersection B. A intersection B will give us just B. So the probability of A intersection B will be the probability of the outcome B, which is 0.3. Alright, so we are going to have 0.3 for this. Now let's find the probability of A union B. Okay, so before you can do that, we first of all have to find A union B. Let's find A union B. We are going to have A, B, C, D, right? So that would be A union B. So you see that A union B is just the sample space, right? And then one thing you have to know is that the probability of all the events in the sample space should add up to 1. Okay, so you should know that when you're computing the probability of A union B, since it is just basically the sample space, we are expecting to get to 1. Okay, so let's actually do the calculation and then confirm this. So we are going to have a probability of A union B, okay, to be equal to the probability of outcome A, which is what 0.1, plus B, which is what 0.3, plus C, which is what 0.5, plus D, which is what 0.1. Okay, so this will give us an value of what 1. So the probability of A union B would be 1. So now let's find the probability of what A intersection C. Okay, so for C, the only outcome in C is in event C is what D, right? So looking at A intersection C, for A intersection C, you're going to get a null, right? So that means that there is no outcome in which is common to event A and C. So for that reason, you're going to have the probability of A intersection C to be equal to what 0. So this is what the this is how to calculate for the probability of what events. Thank you very much for watching this video. Please make sure you like the video and subscribe to the channel.